You know, I've always felt there's a strange paradox in our very physical existence. Your body, my body, appears stable, but at the atomic level, it's a ceaseless flow. An average human carries about 7 Ki atoms according to NIST estimates, and the astonishing thing is that roughly 98% of them are replaced within just 1 year. Your small intestine renews itself in a few days. White blood cells last less than 3 weeks. Skin is completely replaced every 2 to 4 weeks, and even the seemingly solid skeleton is renewed on a roughly 10-year cycle. If the matter that makes up me is constantly disappearing and reappearing, then what makes you feel like a continuous, unbroken entity from past to present? What preserves the memories, hopes, and fears you call yourself? I want you to hold that question in your mind, because if even while alive our bodies are never truly fixed, then death can hardly be seen as disappearance. Perhaps it's just another part of the same physical story, the story of ceaseless change. Let me take you to a very familiar but often misunderstood image. A paraffin candle formula semo burning. When the flame rises, you might think the candle is gradually disappearing, but that's not what happens at all. The hydrocarbon chains are simply oxidized, broken apart, and recombined with oxygen in the air to form CO2, while the stored chemical energy is released as heat and light. Not a single carbon or hydrogen atom truly vanishes. Everything just changes form. 1 gram of candle wax can even produce about 3 grams of CO2. This is the core of the first law of thermodynamics. As Rudolf Clausius stated in 1850, energy cannot be created or destroyed. It only changes from one form to another. And if that holds for a simple candle, it holds for us too. When a human dies, the body doesn't disappear. It reintegrates into larger cycles. Heat radiates away over the first 20-30 hours. Carbon, about 16 kilograms in a 70 kilograms body, returns to soil and atmosphere. Minerals in bones and tissues become nutrients for microbes and plants. Most of that carbon completes its journey back into the global carbon cycle within 1 to 10 years. So death is not a moment of nothing left. It's part of the same physical principle that has governed the entire universe since its beginning. Everything transforms, but nothing is lost. When we look at a candle and realize no atom truly disappears, it opens up a far larger story. One that doesn't begin on Earth or in the solar system, but with the birth of the universe itself. About 13.8 billion years ago, the Big Bang created space-time and the first elements. But remarkably, the Big Bang only produced 3 primordial types of matter, roughly 75% hydrogen, 25% helium, and a tiny trace of lithium. No carbon to build life. No oxygen for you to breathe. No nitrogen in DNA. No iron in blood. All the elements needed for life came much later, forged in the cores of population 2 and 3 stars, enormous structures that burned for millions to billions of years. Inside those stars, temperatures and pressures were so extreme that nuclei could overcome electrostatic repulsion and fuse. The triple alpha process, where 3 helium nuclei combine, produces carbon-12, the cornerstone of every organic molecule. When carbon fuses with helium, it forms oxygen-16, the element that makes up about 65% of your body by mass. In stars more than 8 times the sun's mass, further fusion layers continue through the silicon burning cycle, eventually producing iron-56, the last element that can form through energy-releasing fusion in stars. All of this happened in the silent darkness of deep space, until a massive star ran out of fuel. Its core collapsed, and the entire structure exploded in the cataclysm we call a Type 2 supernova. In just seconds, such an explosion can release more energy than an entire galaxy emits at that moment, hurling heavy atoms into interstellar space at thousands of kilometers per second. Supernova 1987A, 168,000 light-years away, in the large Magellanic Cloud, gave us crucial evidence confirming this nucleosynthesis model, that heavy elements are indeed forged in the spectacular deaths of giant stars. About 4.54 billion years ago, clouds of gas and dust, enriched by thousands of generations of dead stars, began collapsing under gravity to form our solar system. Our sun is a population I star, meaning it contains about 2% metals, the astronomical term for everything heavier than helium. Earth, and every solid thing on it, was born from the leftovers, minerals, carbon, water, metals, all once inside now. When you take a breath, 65% of the oxygen in your body was once forged in the cores of massive stars that died billions of years before the sun was born. The carbon, about 12% of your body, was once ash from ancient supernova. Nitrogen in your DNA and proteins, about 3% of your body, has a similar origin. Even the iron in your blood, though only 0.006% of your body, is the product of collapsed stars. An average person even carries about 0.2 milligrams of uranium and thorium, radioactive remnants from stellar explosions tens of billions of years ago. What's remarkable is that those atoms have lived through countless cycles of formation and destruction, from gas clouds to planets, before briefly becoming part of you in this tiny sliver of cosmic history. When you place your hand on your chest and feel your heartbeat, remember that every atom in there has passed through places no human imagined could reach. Hundreds of millions of degrees in stellar cores, explosions powerful enough to shatter entire celestial structures, and voids across galaxies spanning thousands of light-years. So when I say we are ancient stars temporarily capable of thought, it's not poetic metaphor, it's physical fact. You are a continuation of the universe's story, a story that began with the Big Bang, and will continue long after humanity is gone. And understanding this origin is the first step toward realizing that death is not an endpoint, but merely a moment in the long cycle of matter reorganizing itself. When we say our bodies are made from the remnants of ancient stars, that alone is wondrous enough. But there's another truth that still amazes me every time I think about it. Those atoms, ancient though they may be billions of years old, never stay in your body for even a single moment. They come and go like passengers on a train with no final stop. No one has described this more clearly than biochemist Howard E. Wilson, who in 1953 conducted one of the simplest yet most striking experiments in molecular biology history. Wilson labeled phosphorus atoms with radioactive P32 and tracked their journey in rat brains. Phosphorus isn't an ordinary element. It's the backbone of ATP, the energy currency every living cell uses. It's a key component of DNA and RNA, which store genetic information. It forms cell membranes separating the inside and outside worlds of life. If you want to know whether the brain stands still, phosphorus is the place to look. And the answer came quickly. Within just 14 days, half the phosphorus in the rat brain had been completely replaced. This doesn't just mean energy molecules turn over fast. It means the very physical structures underlying memory, emotion, and thought are constantly dismantled and reassembled. Even no single DNA molecule in your body lasts a lifetime. Most are copied, repaired, or replaced over cell life cycles. In the human body, this turnover is far more intense. Carbon. Literally, the framework of every organic molecule flows through you with every breath, and adult breathes about 20,000 times a day, exchanging over 11,000 liters of air. Every exhale carries away some of the carbon that hours earlier was inside your cells. Oxygen. About 65% of your body by mass lingers only seconds in the blood before becoming water or carbon dioxide and leaving. Nitrogen, essential for proteins and DNA, moves through the cycles of eating, digestion, and excretion no differently from a river's flow. The human body is not an object. It's an open system. As physicists describe structures that maintain form by constantly exchanging energy and matter with their surroundings. Every day you take in 2-3 liters of water, 1-2 kilograms of food, and about 13 kilograms of air. Those become your blood, your skin, your hair, all of it borrowed matter from the world. At the same time, your body expels an equivalent amount. No part of you is materially yours in any stable sense. It's merely passing through. Inside cells, the pace is even more dizzying. Every day your body produces 2 ATP molecules to keep synapses firing, muscles contracting, heart beating, thoughts happening. In the same period, a similar amount of ATP is broken down. About 330 billion cells are replaced daily, according to a 2016 Tedros biology study. Your skin sheds 1.6 trillion cells every 28 days. Even neurons in the brain, though they don't divide like many other cells, continuously replace proteins, lipids, and structural molecules in astonishingly short cycles. When you realize this, a profound question immediately arises. The matter in your brain is constantly changing. What sustains memory? How do you remember events from 10, 20, or 40 years ago? How can you recognize your own voice or feel the on today is still I from yesterday? If you rely on matter, then the you from 2 weeks ago no longer exists. The atoms that made up your story at that moment are now drifting somewhere in the environment, in the air, on a tabletop, or inside someone else's body. And the atoms making you up right now may have been in a leaf, a raindrop, or a fish swimming in the ocean just weeks ago. So if matter doesn't preserve identity, what does? There's only one reasonable answer modern science can offer. You are not the matter that composes you, but the way that matter is organized. You are a pattern, a dynamic pattern, an information and interaction structure, sustained by the continuous flow of atoms and energy. If you want to picture this, think of a wave on the ocean. The wave clearly has shape, speed, direction, but the water composing the wave changes constantly. No single water molecule stays long enough to be the wave. The wave is the behavior of water, not the water itself. And you are exactly like that. You are not carbon, nitrogen, or phosphorus. You are the way they are arranged and operate to produce emotion, memory, and consciousness. Your pattern can persist for decades, even though the atoms composing it stay only days. This also gives us a new perspective on death. If even while alive your body is never truly fixed, how can death be seen as disappearance? Life is a pattern resisting entropy. Death occurs when that pattern can no longer hold its form, but the matter doesn't vanish. It returns to the larger flow of the universe, joining new patterns, trees, animals, soil, atmosphere. And if someday, from those new patterns, another form of life emerges, the atoms that once made you will step into a new story. So when you look at yourself, remember that your material part is only on temporary loan. What truly is you, if there is such a thing, lies in the intricate operation of that matter, not in the matter itself. And realizing this is a crucial step toward understanding that death is not an ending, but a phase transition of a pattern returning to the universe that created it. If the fact that your body is constantly changing at the atomic level forces us to rethink the notion of self, then the next truth is far more important. Humans are not collections of atoms. We are patterns, a pattern of how matter is arranged and operates. Let me take you to the image of a wave on the ocean. When you see a wave, you might think the water is moving toward the shore, but in reality, the water molecules are only oscillating up and down. It's the pattern of that oscillation that moves forward. The wave is not the water, it is simply the way the water behaves, and you are the same. Your body is made of atoms that are always changing, but the pattern, the way they coordinate is what creates your consciousness. In your brain about 10 horde of neural impulses propagate every second. Each impulse is an exchange of ions, molecules, and charge in mere fractions of a millisecond. The brain is not a static structure, it is a continuous flow of activity, a symphony of neural signals, roughly 86 billion neurons, according to Azevedo's 2009 study, form that network. Each neuron connects to anywhere from 1,000 to 10,000 synapses, totaling around 10 horde of nodes connections. That number is so vast that if you counted each synapse at 1 per second, it would take more than 30 million years. Within this enormous network, your pattern emerges: memories, personality, inner voice, fears, love, the choices you've made, and even the things you still hesitate over. What's remarkable is that the brain's pattern changes extremely rapidly. Every 300 milliseconds, the activity structure reorganizes itself. But it's precisely that speed that creates your sense of continuity. Just like a film running at 24 frames per second makes your eyes believe things are moving smoothly. Your brain's pattern operates so quickly that you perceive yourself as an unchanging entity. But the truth is, you are not an entity. You are a process. And every process in the universe is governed by entropy. Entropy, a concept introduced by Rudolf Clausius in 1865, is essentially the natural tendency of all systems to move from order to disorder. Entropy increases is why a hot cup of coffee cools down, why a building decays over time, and why a star eventually exhausts its fuel and collapses. And entropy is also why you age. The arrow of time isn't because the universe prefers to move forward. It's simply the direction in which entropy increases. Because entropy must increase, complex patterns like the human body will eventually weaken. Proteins misfold. DNA accumulates errors. Neurons lose connections. Memories fade. Recovery capacity declines. Not because matter disappears, but because the pattern no longer has enough energy to maintain the intricate organization that performs its function. When that pattern can no longer resist entropy, what we call death occurs. But pay attention. What is lost is not matter. Your atoms are still there, just like water still exists after a snowflake melts. What disappears is the organization, the pattern that made you. And that brings us to a very different perspective on death. It is not destruction, but the disintegration of a temporary structure. Just as a snowflake only exists when temperatures are low enough for water molecules to arrange themselves into a complex pattern, your body and consciousness only exist when there is sufficient energy in order to sustain synaptic activity, hormones, cells, and other biological processes. When those conditions cease, the pattern dissolves. But physically, nothing disappears. This is true not only for you, but at all of the universe. Galaxies are patterns of matter under gravity. Stars are patterns of plasma and nuclear reactions. Snowflakes are patterns of water molecules under low temperatures. Every pattern is temporary because entropy ultimately prevails. But it takes billions of years for entropy to break down a star. For you, entropy wins in mere decades. Yet this does not make you less significant than a star. It only means you are a pattern that exists on a smaller timescale. When you understand that you are a pattern, not matter, you also understand why death cannot be absolute termination. The matter in you, carbon, oxygen, nitrogen, will continue its journey, becoming trees, animals, air, rocks. The energy in you radiates into the environment. But the pattern is gone, because there is no longer energy to sustain the organization. And then we face the biggest question. If the pattern is my essence, what holds that pattern together for decades, while matter constantly changes? The answer lies in the law of organization. Your brain does not copy individual atoms, it copies behavior. When new synapses form, they recreate the pattern of the old ones. Memory is not stored in atoms. It is stored in connections in the pathways neurons have learned to fire over time. That is why you can lose every phosphorus molecule in your brain after 14 days. Yet your memories remain. The pattern is preserved in the structure of the network, in the information, not in specific matter. Some neuroscientists describe this as lighting up a city at night. The bulbs can be replaced every hour, but the map of light, the pattern of the city remains the same. Likewise, you are lit up by the continuous neural process. When the pattern goes out, the darkness is not the disappearance of the city. It is only the stopping of the light. The fact that we are patterns carries a greater meaning. We are the way the universe organizes matter into consciousness for a brief moment. If a galaxy is a pattern of gravity, and a star is a pattern of plasma, then you are a pattern of information. Unlike every pattern, you are only temporary. But being temporary does not make you any less miraculous. A snowflake melts quickly, but is still beautiful. A star explodes and vanishes, but still plays a decisive role in creating heavy elements. And you, a pattern of 10 to quit snits and went. Guess not, synapses exist for a few decades, but in that time you experience the universe in a way the universe itself could not if you were not here. So when you think about death, do not think of the end of matter. Think of the dissolution of a pattern that once organized matter into emotion, thought, and meaning. If you have accepted that humans are merely a temporary pattern sustained by the flow of matter, then let me tell you the journey of a single carbon atom. A journey so long that a human lifetime is like a blink in its story. I want you to imagine you can follow that data from the moment it was born. About 5 to 7 billion years ago, in the core of a giant star 10 times the mass of the Sun, their temperatures reached hundreds of millions of degrees, enough for helium nuclei to fuse in the triple alpha process, creating carbon-12, the most stable and common form of carbon in the universe. That carbon atom knew nothing of its future. It simply existed, compressed in the terrifying pressure of plasma, a tiny part of the nuclear ash accumulating in the star's core, and then that star died. When its fuel ran out, the core collapsed in milliseconds, and the entire star exploded in a Type II supernova. In that instant, the star shone brighter than an entire galaxy. The explosion hurled our carbon atom into space at thousands of kilometers per second. It traveled through endless darkness, becoming part of the Orion molecular cloud, a stellar nursery about 1,344 light-years from Earth, where dense gas and dust began collapsing under gravity. Over the next 100 million years, a timescale far beyond human imagination, the carbon atom drifted, mingling with hydrogen gas, silicon dust, oxygen, magnesium, and other atoms also born from dead stars. Then one day, a portion of the Orion cloud collapsed strongly enough to form a young star. Around it, a protoplanetary disk of gas and dust began to take shape. This was the early solar system. Our carbon atom was drawn into that disk. Some of its companions became part of Mercury, Venus, Mars. Some became asteroids. This carbon atom ended up compressed into a piece of carbonate rock as Earth formed about 4.54 billion years ago. For hundreds of millions of years, it remained trapped in limestone minerals, enduring geological eras, without changing. A carbon atom under stable conditions has near infinite longevity. It can outlast every species on the planet. And then Earth stirred. Volcanoes erupted. The rock containing that carbon was heated, decomposed, releasing CO2 into the atmosphere about 200 million years after Earth formed. It drifted with the wind, dissolved into the ocean, then returned to the air about 50 million years ago. That carbon was absorbed by a leaf through the Calvin cycle. The process plants use sunlight to turn CO2 into glucose. From glucose, it became part of cellulose in plant tissue. Was the plant eaten by a dinosaur? Quite possibly, or decomposed by fungi, releasing the carbon back into the atmosphere. For matter, every path is possible. About 30,000 years ago, that carbon was inhaled by an ancient Homo sapiens, incorporated into bone or soft tissue, then exhaled or reused. As our ancestors migrated, survived, and adapted, carbon moved with them from one body to another. Through campfires, trees, soil, hunted animals, carbon knows nothing of life. It simply follows the laws of physics. And then the strangest moment in that entire carbon atom's journey is right now in 2024, when it sits in the bones of your hand, or in the body of the person listening to these words. A carbon atom that passed through stellar cores, supernova explosions, molecular clouds, primordial planets, volcanoes, ancient plants, prehistoric animals, and human atom stores, is now quietly inside you. You may not realize it, but your body contains about 16 kilograms of carbon, and every atom in it has its own history. A history longer than all of human civilization. And one day you will die. When that happens, you're patterned. The way matter organizes itself into consciousness dissolves because entropy finally prevails. But the matter in you, it does not disappear. Not at all. The carbon in your bones will break down, release into the soil, be absorbed by plants, enter tree trunks, leaves, then insects or animals. Some may enter the atmosphere as CO2, become nutrients for the ocean, or be released again by volcanoes in the global carbon cycle. That cycle currently exchanges about 210 gigatons of carbon each year between atmosphere, land, organ, some and oceans. One day the carbon atom that was once in your hand may lie in a leaf on a tree on another continent, in a butterfly's wing, in the shell of a sea creature, or even in another human's brain. Perhaps it will become part of a life form yet to appear on Earth. Perhaps it will lie silently in a rock for millions of years. The point is, carbon will continue its story. A story that stretches billions of years before you appeared, and will continue billions of years after you are gone. And that is why I want you to see that death, in the physical sense, is only a tiny point in the very long journey of matter. You only possess carbon, oxygen, nitrogen, temporarily. You did not create them, and cannot keep them. You borrow them from the universe, so your pattern can exist for a while. When the pattern dissolves, the matter returns to a far greater journey, and if you look at it this way, you will find something more comforting than any doctrine. You do not truly disappear. Only your pattern ends. That carbon atom story continues, and you for a moment were a wondrous chapter in its journey. Who knows where that atom will go next? It may lie in a forest that grows after you are gone. It may be part of the next generation of humans. It may return to a new star billions of years from now. Death does not close the journey of matter, it only changes its direction. And when you understand that, You realize, we are not creatures separate from the universe. We are the universe, reorganizing itself, finding ways to understand itself. In this brief moment before returning matter to the endless cycle of time and space. And so as we reach the end of this journey, I want you to remember one simple but profound thing. Death is not your disappearance, but only the end of the pattern that once was you. That pattern, the way billions of neurons in your brain coordinate, the way memories are recalled, the way you love, hope, fear, exists only when there is enough energy to resist entropy. The matter that makes you up does not disappear at all. It simply changes form and continues its story in new patterns of the universe. This is not metaphorical philosophy, this is physics. The law of conservation, which has held true since Rudolf Clausius in the 19th century, states clearly that energy and matter cannot be destroyed. When you are alive, your brain, which is only 2% of your body weight, consumes up to 20% of your total energy, not to maintain atoms, but to maintain the pattern, and when that energy runs out, the pattern ends. But the rest of you, carbon, oxygen, nitrogen, calcium, atoms, with lifespans measured in billions of years, continue their journey. If the average human life in the United States today is about 79 years, to an atom that is merely a fleeting moment, this does not diminish your value. On the contrary, it makes your existence precious. The universe took 13.8 billion years, a long chain of stars forming and dying, nuclear reactions blazing and fading, planets born from stellar dust, to produce a creature capable of looking back at the universe and wondering about its place in it. You are one of the rare ways the universe becomes self-aware. So death does not negate the miracle that you once existed. It does not take away the fact that matter was once organized into a special form we call you. That from chaos emerged a pattern capable of thinking, feeling, and questioning its own origin. And before we conclude, I want to leave you with one question. Not a question for science alone, but for you personally. If you are not your atoms, but the way they operate, then what makes you truly you? And what in that pattern? A memory, an act of kindness, a story you told, a change you created will continue in others, in other memories, in new patterns of the universe. We may exist only for a flash, but that flash is enough for the universe for the first time in its long history to know that it exists. If you want to join me on the universe's next journeys, please subscribe so you don't miss any part of this story. See you in the next talk, where we will continue exploring the wonder of existence itself.